Welcome to this YouTube video, and in this video we're going to be looking at exact differential equations, right? So we're going to understand what makes a differential equation to be exact, right? We're going to look at how we can identify it. Also going to look at how to solve them, right? So we have the base case, which is what we're going to be doing in this video. We're going to solve two questions on the base case, and then in other videos we're going to look at the other 5 cases that we have. Right, so let's get into the video. For this question, or for this exact differential equation, they come in the form of m dx plus n dy equal to 0, right? They come in the form of m dx plus n dy equal to 0, and they must satisfy the condition of the m over dy is equal to the n over dx. They must satisfy this condition. So that means after you have found the derivative of m respect to y, it must be equal to the derivative of m respect to x. That is the basic ideology. So now, looking at this, you'll be wondering, this looks very similar to the homogeneous equation. So why do we not do homogeneous equations? I will show you as we take this example. All right, so let me write this out. So we have here our first question for this video. We have 5x to the power of 4 plus 3x squared y squared minus 2xy cubed dx, right, is equal to, no, sorry, plus, not equal to. So we have plus in bracket 2x cubed y minus 3x squared y squared minus 5y to the power of 4 dy is equal to 0. So we have this question now, and you may be wondering, why can we not use homogeneous equation? Now this is the thing. Yes, it may be possible to use homogeneous equation, but if you are being given a question like this, it is be wise for you to first check if it is going to be exact, right? Because it is easier to check if it's going to be exact. So how do you check? You're going to find your m and you find your n. Then after finding that, you're going to find the n dy and find the n dx. The moment you find this and you see that it is equal to each other, then you are going to solve using exact differential equations, right? Because it is easier to solve questions using the exact differential equation method than using the homogeneous method, right? But then again, it does depend on specific conditions, right? The homogeneous equation have their own conditions, and this one, the exact differential equation, also has its own conditions, right? Which is the m dy must be equal to dn dx. Now what is our m, right? According to this formula that we have above, this is going to be our m, and here is going to be our n. Our n is what is with dy, and our m is what is with dx. Very, very simple. So we're going to have m to be equal to 5x to the power of 4 plus 3x squared y minus 2xy cubed. And now we are going to find the m dy. So which means we're going to find the derivative of m with respect to y. So any other variable is going to be a constant, right? So all this x that we have in this m is going to be a constant. Only the value of y is going to be the variable that's going to be dependent, right? So now 5x to the power of 4 is going to give us 0, right? Because x is a constant, we're taking it as a constant, so it's going to give us 0. Then we have plus 3x. Okay, so this 3x squared y squared, right? Alright, so we have 3x squared y squared. Now if you differentiate with respect to y, so you're going to have 6x squared y, right? And you're going to have minus 6x y squared, and that is for dm dy. So now we're going to check for n. So n is equal to 2x cubed y minus 3x squared y squared. Then we have minus 5y to the power of 4, and then we're going to check for dn and dx. So dn dx is going to be equal to so this one we're differentiating with respect to x, right? This will give us 6x squared y minus 6xy squared, and then this one minus 5y to the power of 4 does not have an x, so that means it's a constant and it's going to be 0. So now this is going to be equal to 6x squared y minus 6xy squared, and this is going to be equal to 6x squared y minus 6xy squared. So now we can see that this is equal to this, so that means the condition is verified. So because it is verified now, we are going to go ahead and we are going to solve the question, and it's a very, very simple method. That's why it is always better to check if it is exact. If it's exact, you can just start rejoicing, because in the next 1 minute you're already done with your solution, right? But if it's homogeneous, you still have to spend a couple of minutes trying to wrap your head around it. All right, so now let's solve this question. All right, so now since it's exact, we know it's exact. Basically, the formula is just basically the integral of m dx plus the integral of n dy is equal to c. This is basically the formula, right? But there is a condition to this. Whenever you are integrating for m, you integrate with respect to x, making y a constant. But when you are integrating for n, you are only going to integrate the value of n that has only y. If the value of n has x, you are not going to be integrating it. So now let's look at n now. N is this, right? This part of the question here. This is n. So this one that has x now, we are not going to integrate it. We are not going to integrate this. We are only going to integrate minus 5y to the power of 4, right? So minus 5y to the power of 4 is the only thing that we are going to be integrating, right? Because that is the condition for exact differential equation. But for m now, we're going to be integrating every single thing with respect to x, making y to be a constant, right? So we're going to have the integral of 5x to the power of 4 plus 3x squared y squared minus 2xy cubed dx plus the integral of n. But n now, we're only going to be integrating minus 5y to the power of 4 dy is equal to c. So that is the condition that was given for this question. So now if we should integrate 5x to the power of 4, we are going to get 5x to the power of 5 over 5. The 5 will cancel out the 5, so we're going to have 5 to the 5 x to the power of 5. Then we're going to have plus 3x squared y squared. Remember, y squared is going to be a constant, right? Only x is the variable that we are depending on. So that means 3y squared is going to be a constant, and then we're going to integrate x squared. X squared in the integral is going to give us x cubed over 3. The 3 will cancel the 3, so we're going to have x cubed y squared. Now, when we differentiate 2x y cubed, the minus 2y cubed is going to be a constant. We're going to integrate x. We're going to get x squared over 2. The 2 will cancel the 2, so we're going to have minus x squared y cubed. And that's for that part. And then for the y side, we're going to integrate minus 5y to the power of 4. Minus 5 is going to be a constant. We're going to integrate y to the power of 4. We're going to get y to the power of 5 over 5. The 5 will cancel the 5, so we're going to have minus y to the power of 5 is equal to c. And this is our answer. So very, very simple stuff. It is not stressful at all. You can easily get your answer using this exact differential equation method. Very, very simple. The only thing you need to do, just check the condition. Is the m dy equal to dn dx? The moment it is equal, then you are going to just integrate the value of m with respect to x, and then integrate n, the values of n that contain y alone. So once you do that and you equate it to c, and then you're good to go. So we're going to take one more question on this, something more complex on exact differential equation, so that we see exactly the extent to what we can do with the exact differential equation. Right, so let me clean this off so I can write out the second question, and then we can move on from there. Right, so yeah, we are going to have this very interesting question. Right, now on seeing the question at first glance, it might look to be very, very strange, because indeed it is strange, but it is very, very easy. That's the power of mathematics. So we have 1 plus 3e to the power of x over y, right? Then we have the x plus 3e to the power of x over y in brackets 1 minus x over y dy is equal to 0. And you may be wondering, oh, this one is going to take our time. It's actually not going to take your time. The moment you know the nooks and crannies, then it's going to be easier for you. All right, so now let's look at this question. Right, so first we're going to bring out our m and bring out our n. Right, so our m is going to be 1 plus 3e to the power of x over y, and then we're going to differentiate it with respect to y. Right, remember we're looking for dn dy and dn dx. So now if we differentiate 0 with respect to y, we're going to get 0, and if we differentiate 3e to the power of xy with respect to y, basically you're going to make x the constant, right? And that is going to be x times y to the power of minus 1. And if you differentiate y to the power of negative 1, you're going to get negative 1 y to the power of negative 2, right? So you're going to be having, then you're going to multiply with x as well, right? So you're going to have plus 3 multiplied by negative x, right? Because negative 1 over y squared, right? So we're going to have negative x over y squared multiplied by the exponent itself, right? Let me just come again if you did not get that, right? So we have e to the power of xy, and we are differentiating with respect we are differentiating with respect to y, and here we have x over y, which is the same thing as x y to the power of negative 1. So this x is going to be a constant. We're going to take it like a number, right? So we're just going to differentiate y to the power of negative 1, and then when we are differentiating, we're going to have negative 1 multiplied by y, negative 1, negative 1. So that's going to be negative 2, which is going to be equal to negative 1 over y squared, and then we're going to multiply it with x. We're going to have negative x over y squared, which is what we have right here, right? So let me just go ahead and clean this off so that we can continue solving. So I'm going to clean this part of the question. Alright, so now that we are done with that, we're going to go to our next variable, which is n. So we're going to have n to be equal to 3e to the power of x over y in brackets 1 minus x over y, right? So I'm going to simplify this by multiplying out. So we're going to have 3e to the power of x over y, then I'm going to have minus 3e to the power of x over y times x over y. Now one thing I'm going to do here is I'm going to factorize 3 out, right? This one I'm going to factorize 3 out is because 3 is a constant, right? So that it is easier for us to solve. So we're going to have 3e to the power of x over y minus x over y times e to the power of x over y. So we have this now, and we're going to find the n dx of that expression. So we're going to, 3 is a constant basically, right? So I'm just going to put it and then open my bracket. So now I have e to the power of x over y. Remember, this time around we're differentiating with respect to x now. So if you differentiate e to the power of x over y with respect to x, when you differentiate x you get 1. So that's basically just 1 over y. So you're going to have 1 over y e to the power of x over y. Then you're going to have x over y times e to the power of x over y. So for that part of the question, you're going to be using product rule, right? Because we have x over y multiplied by e to the power of x over y. Now when you differentiate x over y, you're going, because you're differentiating with respect to x, you're going to get 1 over y. So you're going to have negative 1 over y, then multiplied by the second expression, which is e to the power of x over y. Then you're going to go to e to the power of x over y, then you're going to differentiate that and multiply by the second expression, which is x over y. So now differentiating e to the power of x over y with respect to x, you're going to get 1 over y. So I'm going to have negative as well, 1 over y. Then you're going to have multiplied by e to the power of x over y, then multiplied by the second expression, which is x over y. Then you close your bracket. So right about here, this is going to cancel out this, and then we have this 3 on the outside. We'll multiply this, so we're going to have negative 3x, this x that's here, negative 3x, that's 3 times 1 times x, that's negative 3x over this y multiplied by this y. So we have y squared, and then we have e to the power of x over y. So I want you to look at this expression. If I simplify this expression here, I have negative 3x over y squared e to the power of x over y. Now check the m and check the y, check the m dy, check the m dx, and you're going to see that it is exactly the same. So that means it satisfies this condition, and that means it is an exact differential equation, and we can solve it using the methods of exact differential equation. So now that we have gotten this, what is left for us now is to just apply our very simple formula, and this is why I love exact differential equation so much, because it is, I think it's the easiest of the bunch, right? The moment you verify the condition, then it is very easy from there. So what do we have to do? We're just going to integrate m dx plus the integral of m dy is equal to c. Now remember, for y, you're going to only integrate the part of y that has y alone. The part of n that have y alone. The moment it has x, you're not going to integrate it, right? So we're going to have the integral of 1 plus 3e to the power of x over y with respect to dx, plus, now if you check for n, you will see that there is no part of dy of n that has only y variable. All of them has x, right? So that means we're just going to be integrating 0 is equal to c. Very simple. It just makes our work very much easier. So here we have 1 plus, so now when we integrate 1, we're going to get x, and now when we integrate 3e to the power of x over y, remember we're integrating with respect to x. Now when we are integrating e to the power of x over y, first we are going to first differentiate x over y with respect to x, and when we do that we get 1 over y. So that means we're going to have plus 3e to the power of x over y, then divided by 1 over y, which is basically going to be times y, right? So we're going to have 3y, and then this is going to be equal to c. If you do not understand how we integrated 3e to the power of x over y, you can check the previous videos on the channel, but let me just reiterate because I think we're already done with the video, so let me just do that. So we have 3e to the power of x over y. So when you are integrating such an expression, right, what you do is that this exponent, the power of the exponent, you are going to differentiate it, right? So we're going to take the derivative of x over y, and since we are differentiating with respect to x, it means that 1 over y is a constant, right? So we have 1 over y x. Now when you differentiate x, you get 1, so you have 1 over y times 1, so that means the derivative is 1 over y. So now basically this 3 is a constant, so you're going to have something like this, 3e to the power of x over y dx. Now that we have differentiated, so we're going to have 3 in bracket the, because when you integrate an exponent, it still remains an exponent, right? So you just differentiate, so you're going to have e to the power of x over y, right? And then you're going to be dividing by the derivative, which in this case is 1 over y. So we have 1 over y. So we're going to have 3e to the power of x over y, then divided by 1 over y, and this is going to be 3e to the power of x over y times y. So that's why we have 3y e to the power of x over y. Very, very simple, and this is all on exact differential equation of the base form.